Okay, so yesterday, you guys continued to work on some radicals and stuff like that. So we're just going to continue with that. Okay, so this formula that you see right here, this is the escape velocity needed to escape Earth. Okay, so the related and important variables there. Mass of the planet, and this formula can be used on any planet, okay? Any planet or any star. This talk, except for you're not going to really be on a star, right? You'd be burning. But yeah, so you can use this escape velocity for any planet, and the important variables here is G, which is the gravitational constant that was calculated by Cavendish. R is the radius and the mass also, okay? And then over here we have our escape velocity, that's VE. Okay, so the rocket of the New Horizons probe is so powerful that the probe escaped the Earth's gravity, right? It's pretty strong. Like for us to get out of Earth, we'd have to go be in like a spaceship.
Yeah.
Right? So yeah. Escape velocity is the speed an object needs to break free from the gravitational pull of another object. At the surface of the Earth, the escape velocity for an object is 11, it's a bit above 11,000 meters per second. That's fast. 11,000. Anybody know how many meters per second we move on the highway at like highway speeds at 120 kilometers per hour?
I'm gonna go with
3
meters per second. Are you kidding?
It's
Like
higher than
I'm gonna
three.
say like 46.
Lower than that.
30.
30.
What did you say?
30.
30? Yeah, it's about 33. So if you're driving at 120 kilometers per hour in meters per second, that's like 33 meters per second, which is actually pretty quick. What do you think about that, right? But yeah, so to get out of Earth's orbit, you need to go like 300 times faster than that, right? Like that is quite fast. That's okay. Actually, you're even gonna have to go faster than that because that would only be 1,000. But no, that'd be right. Anyways, okay, so we have this formula here, and now we are gonna actually do a little bit of algebra here. We want to isolate for m, right? So if we have our escape velocity is equal to the square root of 2gm over r, how can we use this formula to determine m? If we knew, well, we do know the escape velocity of Earth. We know the radius of Earth is right here, and we know the gravitational constant. So if we know this, and this variable, we can solve for m, but how would we solve for m, Logan?
Say you try and get rid of the m and times it by itself.
Yep. Yeah, so we're gonna like do some algebra here to get our m by itself, right? Right now it has like the square root and multiplied by 2g and divided by r. So let's do opposite operation. So the opposite of taking the square root of something is
Taking or if you're gonna take the square root, it'd be the opposite of multiplying.
yeah, or squaring it, like multiplying by the same thing. Yep. So we'll square each side. The square root and the square will cancel. Now I have VE squared is equal to 2gm over r. And remember, we're solving for mass here, right? So if we're dividing by r, we should multiply both sides by r. Those cancel. And then lastly, to get that m by itself, we'll divide by 2g. Okay, then we'll get mass is equal to the radius times the escape velocity squared divided by the gravitational constant multiplied by 2. Okay, so we can do a little bit of a manipulating here. If you took physics 20, you would play around with this formula a little bit more. Okay, yeah, solving for that, we could just substitute in our R value here, our G, and the meters per second. So let's go ahead. Let's find the mass of Earth. So R is 6.38 times 10 to the 6 meters. Escape velocity is 11,172 meters per second, and this is squared, divided by 2 multiplied by g, which is 6.67 times 10 to the negative 11. So 10 to the negative 11 Newton meter squared per kilogram. It might be kilograms, or yeah, it was.
Wait, times by 10 and 11 Newton.
Times 10 to the negative 11. Yeah. Times 10 to the negative 11. Okay. So then we'll punch these into our calculator and see what we get. And just be careful on your squared, because we only want to square our escape velocity.
So that equals 7.03
I think we're honestly gonna don't know.
Okay, we get a mass there of 5.97 times
What's
10.
that exponent that you?
Oh, it's 10 to the 5.
Which one? This one?
Negative 11.
This one is negative 11, yeah. So from that, you can calculate the mass of the Earth, which is 5.97 times 10 to the 24 kilograms. And because I have a Physics 30 formula sheet, let's check our answer. And that is exactly the mass of the Earth. 5.97 times 10 to the 24 kilograms.
I don't know what I got, but
Were you careful with your brackets and exponents and stuff?
I didn't even use brackets. I'll like just offset it. But I probably should have used brackets then.
Brackets are your friend. Brackets are your friend. Okay, so we can do that. We can manipulate stuff like that to solve. We can mess around with equations. Okay. Okay, so let's talk about some terminology today. Okay, so this thing right here, that n, that says what root it's going to be, right? If it's like a 2, it's a square root. If it's 3, it's a cube root. If it's 4, it's a fourth root.
So that's just n for your group.
This is n, yeah, and we call this the index. Okay? The index is like what we're doing. This whole unit here, we call that the radical. So that includes the square root. Okay? And then what is underneath the square root, we call that the radicand. Yeah. We call that the radicand. Okay? There are two ways to show a radical. So we have a mixed radical. So this is where we have like a number out in front and then a number inside the bracket. Okay? This is when n does not equal 1. And then we're going to have an entire radical. So something like this. And this is where n does equal 1. Okay, so then you'll just see it like this. Right? Anything multiplied by 1 is what, Brandon?
Huh?
Anything multiplied by 1?
It's gonna be that number.
It's going to be that number.
Yeah.
That's right.
Yes, Brennan!
Okay. Any questions about that so far? These terms are going to come into play a little bit later on, so they are kind of important. So whatever is underneath it is the radicand, and then whatever root we are taking, that is the index. Okay? Sweet. So let's convert entire radicals. So remember, an entire radical is something like this, right? There's no number in front. Okay? So, and remember, we're just going to use prime factorization. I think that's the easiest, right? Do we like that? Prime factorization? That's not too bad, right? So what do? Then,
Find all the multiples of 80.
yeah,
So
Go
1,
40 and
80,
two.
2, and 40.
yeah. So don't do 1. I mean,
Oh,
well, what
I
are you
just
what are you gonna get if you do 1?
40.
It'll just be 1 and 80, right? And then you'll be right where you started.
Yeah.
Okay, so always, if it's an even number, I would start with 2. Okay, and we'll just keep going. We're going down. So how do we get to 40? It's 2 times 20. How do we get to 20? It's 2 times 10. To 10 is 2 times 5. Can we reduce 5 anymore?
No.
So then you have 2, 2, 2, 2, 5.
Yep, perfect. So then we have square root, and then 1, 2, 3, 4 2's, and a 5. Okay, we are taking the square root here, right? If it doesn't indicate the index, you assume it's a square root, okay? So square root, we're looking for numbers that we multiply twice, right? So if I see a 2 here, or 2 2's rather, then I'm going to take those outside of the square root, right? So then I'll have 2 square root, 2 times 2 times 5, right? But what do we have there, Cody?
We have 4 2s, or another pair of 2s.
Yeah, another pair of 2's. So we're just going to take those outside.
So it'd be 4 square root 5.
Yeah, perfect. It'll be 4 square root 5. Absolutely.
This next
And-
one's gonna be a little bit more difficult.
Sorry?
This next one's gonna be a little bit more difficult.
You think so?
Oh, yeah.
Yeah.
Same process though. How could we check our answer?
Well, I'll go 4 square root 5.
Yep, exactly. And you could also do the root 80, right? Just to make sure that they are the same. Okay?
Okay, what the hell?
Should be alright.
4 square root 5 bracket equals. Why do I keep getting 8.9?
And then what's root 80?
What's that?
What's root 80?
Second square root 8.9, okay.
Same thing, right? Great.
For some reason I was thinking that 4 to the square root of 5 was 80.
Oh, no. Same thing. Okay, so next one, 288. Index is what here, fellas?
What's that?
What is the index?
The
Square.
just be.
Index is this number right here.
There'd
There's
just
no
be
number, so
1.
we assume it's square root.
Yeah, so the index is 2.
So
Okay.
then
Then yeah, so we're just gonna break this up, right?
So
So
you
then
go
I-
144 and 2.
Yep, perfect.
144 divided by 2. 72. And then 72.
Can't divide.
36.
Oh yeah, never mind.
2.
36, and then you have 36.
That's what I got.
18.
Which goes down to 2 and 9, and then 9 gets broken up to 3 and 3. Okay, so I got 1, 2, 3, 5 2's. What's up,
I
Logan?
thought I did. Never mind.
I mean,
No,
it's
If you do it differently, too,
yeah, I did like 36, like divided by 6.
okay, so you did 6 and 6 for yours?
Yeah.
Yep, and that's okay. We'll get the same answer.
Okay.
It doesn't have to be the same, right? Because eventually it's all gonna be broken down to like 2's and or prime numbers, right?
Yeah.
So I have 1, 2, 3, 4, 5 2's.
3, so you go 5 square
Oops.
root 3, 3.
And
Then you can just go 5 square root 6.
2 3's. So I have 4 2's. So I'm gonna take all 4 of those out, obviously, and I also have 2 3's.
Yeah.
So if I take out 2 2's, I put a 2 out in front, right?
Oh shit, I forgot about that.
But if I take out 4 2's, I'm going to be taking out 2 multiplied by 2, right?
Yeah. 4.
Excellent, right? So if I take out 4 2's, it's actually going to be 4. So I'm going to have 4 root, and then 2, 3, and 3.
Yeah.
Now I have 2 3's, which I'll take out.
So 6.
And I already have a 4 out there, and I'm multiplying it by a 3.
So 12 to the square root of 2.
Excellent. 12 to the square root of 2. Okay, and if you don't need to do this extra step, that's totally fine. Okay, but what do you guys get if you have more work down? Potentially.
More potential marks.
Yeah, exactly, right? So, never hurts. Okay. What's our index?
3.
3. Good. So we're doing perfect cubes, or whatever, we're doing the cube root of this stuff. Okay, so, same thing we've been doing. We'll take 432, we'll break it up into 2,
216.
216, then we have 2 and 108, 2 and 54, 2 and 27, 27 goes down to 3 and 9, and then 9 goes down to 3 and 3. Okay, so I got 1, 2, 3, 4 2s and 3 3s. Okay, and we're taking the cube root. So I'm going to take out 3 2s, and I'm going to take out 3 3s. Okay, so I'm taking out a 2, or well, 3 2s and 3 3s, so I'm going to multiply those together. So 2 times 3 is 6. Okay, so then we'll get 6 cube root of 2.
Oh, shoot, I messed it up.
Where'd you go wrong, Cody?
I had, for some reason, I had 36 square root 2. I went 2 plus 2 plus 2, so I had 6, and then I went 6 times 6.
Okay, gotcha. Yeah, so make
Oh,
sure
first of all,
we're multiplying, right? When we're taking out the roots,
Yeah.
we're multiplying. Yeah, and that's okay.
Oh,
Can we tell Brendan gets back though?
buddy.
Well,
Brendan goes home
Yeah,
and
they-
just plays Fortnite.
pick that up with him. You guys good?
Yep.
Okay. Okay. What do we have here? What's our index?
2.
Index is 2. What else have we thrown in here just to mess with you two?
Square root and a letter.
Letters, right?
Yeah.
Letters. Okay, we're getting a little bit better at this, so we gotta make it a little bit challenging.
Is it like the unknown number? Like,
Yep, because that's what a variable is, right?
alright.
But we're gonna, so when you see something like this, I will encourage you to do them separately. Okay, so let's just do the number first, and then we'll deal with the variable second, okay? Index of this is what?
2.
So we're just taking
This is just the,
just the square root, okay? Perfect. So let's break up our 175. I know there is a 5 in there, so it has to be divisible by 5. You could, and there's a few ways that you guys could do this.
35.
Is that what you got? Was 5 and 35, Logan?
yeah.
Yep.
Okay, let's do that.
And then.
And then we'll get 5 and 7. And that's, yeah. I did it 25 and 7 the first time, but we still got to the same answers.
Yeah.
So it's totally fine, right? Okay, so we've done our number. Now let's do our variable. How do we get to n squared?
Divided by.
No, you
Try
don't.
and get rid of ones.
No, that's getting rid of them. You'd have to if you want n squared, you have to go n times n.
Yeah, perfect. Okay, so n times n to get n squared. Good. Okay, so now we have these
7 and 2 n.
and we have this, right? So let's go ahead and put that in over here. So I have 5, 5, 7, n, and n. Okay, we're taking the square root. Our index is 2. Okay, so I want to take out 2 5s and 2 n's.
Be.
So that'd be 10 squared.
Nope,
It'd be 5. N squared.
nope,
10n squared.
nope. I like the 5.
35n squared.
Okay, let's think about it this way, okay? So
25.
So 5 times 5 is 25,
25,
and then you take the square root of it and you get 5, right?
Yeah.
That's why we take that outside, right?
Oh, 5n squared.
5n squared, yeah. I
Okay,
said that first.
okay, but if we multiply n by n, we get
Oh,
n
it's
squared.
just 5 squared.
If we multiply n by n, we get n squared,
Yeah.
and then if we take the square root of n squared, we
5n.
get
And
n, right? Yeah, so it'll be 5n is what we're taking out, and then 7. Okay? Same, like we're gonna treat our n's just like we would our numbers, right? If we have 2 of them, we just take that number out,
yeah.
right? Okay, 5n root 7 for sure. Okay. 8a cubed. Okay, so what's our index here?
2.
4 times 2.
What?
What?
Our index? What's our number here?
Square root.
Square root, okay. So again, do the number first and then do the variable second. So 8, how do we get to 8? 2 times 4. How do we get to 4? 2 times 2. Okay, and then a cubed. How do we get to a cubed?
It'd have to be it'd have to be a squared plus a.
Okay,
Or a squared and a.
multiply, right? And then how do we get to a squared?
Just a squared.
A times a, right?
Yeah.
So we have
3 a's.
3 a's and 3 2's. So 2, 2, 2, a. Our index is 2, so we're going to take 2 of these things out.
So it'd be 4.
2.
So it'd be 2 and 2 is 4, or times square root of 4 is 2. So 2, and then you have,
2a's. So
and you take,
it'd be
It'd
2a
just be
divided by.
no, just
no,
be
wait,
2a, square root.
2a square root of 2a.
Yeah, good. 2a square root of 2a. You bet. And Cody, if it helps you to go, okay, 2 times 2 is 4, and then the square root of 4 is 2.
Yeah.
That's awesome. You could also say, well, we're taking the square root, and I have 2 of them, so I'm just going to take out that whole number.
Yeah.
It just saves you like a mental calculation,
Yeah.
which is fine. We need those sometimes, right?
Yeah.
Okay.
Is this just the same? Oh, wait, hold on.
Yeah, a little bit, but this, we have a mixed number and we're still gonna simplify them, okay? So sometimes when a question says simplify, this means that the number under the root is not as low as it can be, right? We always wanna write things in the simplest possible manner, right? Okay, so for this, leave out your number, which is out front. Okay? Leave that one alone for now, and let's just break up the 52. Okay? So how do we get to 52?
2 and 26.
Yep. And then 2 and 13. What do we know about 13?
You can't, that's the lowest it's going.
What do we call that?
I don't know.
It's a prime number.
Oh, prime number.
Prime number. Okay?
Wait, so we're gonna have 2, 2, and 13.
Okay, so yeah, so let's go. So for root 52, here are our factors.
Yeah.
So let's rewrite this as 4 square root of 2 times 2 times 13. Okay? We are taking the square root, right?
Yeah.
And I see 2 2's. So what are we going to do with those 2 2's?
Well, you're gonna.
It'd be 4 and 4th root or whatever. So, hold on.
No.
Yeah.
What were we doing on the last page when we were
We were-
simplifying?
When you're simplifying, well, we take our
It'd be-
variable and like we'd add on to our number. So
I know. I think I know.
What do you got, Logan?
I think it's 8 4th root of 13. So I think that I don't know.
Okay, yeah, so, and just be careful about the 4th root, because we're only taking the square root here, right? We don't see, like a 4th root, right?
Oh,
This
yeah.
this is a mixed radical,
Oh.
okay, remember
Okay.
mixed radicals? we see it like this, right?
Okay.
Okay, so it's not that we're taking the fourth root. It just
Yeah.
says that we have a 4 root.
Yeah, just in front.
Yeah, but you are right.
Okay.
You are right. Yeah. So right here, because we're taking the square root and we have 2 2's, we're gonna take those 2 out. And if we're taking the 2 out, then it becomes 2 times 4 times root 13, which is equal to 8 root 13. Is that okay?
Yep.
Okay. A negative. What do you think we should do about the negative, Cody?
Probably make it a positive before we solve.
Why?
Because you can't square root a negative.
You definitely cannot square root a negative. You're right. So let's just leave that negative alone. Just pretend it doesn't exist. And then once we simplify it, then we'll put it back on there, okay? Does that sound like a plan?
Yeah.
Okay, so 252.
Divide by 2, you get 126. And divide that by 2, you get 63. And then
That's 9 times 7. 7 is a prime number, okay? So, I'm gonna oh yeah, and then we also have our variables here. How do we get to a squared?
A and A.
Yep, a and a. And not the Alcoholics Anonymous.
Yeah.
Yeah. Yeah. Okay, so now we know our factors, right? So let's just leave our -6 outside. And then we'll put everything else inside of it, okay? So I have 2 2's, 2 3's, and a 7, and 2 A's. Okay, what is our index here?
So the 7 would stay inside because it doesn't have a pair.
Yep,
And then it
Take
would
the 2
be
pairs.
but are we taking the cube root or the square root? Or a fourth root here?
Square root.
Square root. Good. So we're looking for pairs.
yeah.
We're looking for pairs.
So it'd be 2 and
Okay, so let's just do this one at a time, okay? So I'm gonna bring our 2's out first. So -6 times 2.
6A7.
And then we're gonna have 3 times 3 dot A dot A dot 7. Okay? So then we get -12.
Are we not taking the pair of 3's out?
Sure, yep, let's take those out now. Okay? So we'll take out these 3's, so then we get -36. A7. Now we can take out those A's. And we'll get -36 A root 7. Okay, so when you see a negative, just kind of leave it alone out there, okay? Yeah. That's it. How we doing?
Good.
Cruising? Okay, so convert a mixed radical to an entire radical. What was an entire radical? Who can remind me?
It equals 1. Yeah.
So there's just no number out front, right?
Yeah.
Essentially, so give me an example of an entire radical.
Just nothing and then a number. Square root and a number.
So square root of 52.
Yeah, that works.
That's an entire radical, right? And then yeah, what you said, your n, Cody, this just means that we have a 1 out in front, right? Okay. Okay, so if we have, so now we're going to go into an entire radical, right? So if we're taking the square root of 4 root 5, if we took out a 4 and it's a square root, how many 4's did we have in there before we took it out?
16.
Yeah, and then what are the factors of 16, Cody?
2 and 8 and 2 and 4.
4
2 and 2.
4 and 4, right? So if we took out
Yeah,
if we took out a 4 on a square root, we know that it is the same thing as 5.4.4, right? Is that okay? Okay? So then, if we're going from a mixed radical to an entire radical, we're just going to multiply those numbers.
yeah.
Okay, so 5 times 4 is 20, times 4
It's 100.
20.
80.
is 80, right? So, is 80. Okay? And you could check your answer. Okay, you could just do 4 root 5 and then do root 80 and you will get the same value. Okay, so we've taken the square root, right? So, and again, we're going to leave our negatives alone. So if we've taken out a 5, how many 5s did we have?
2.
2, right? And then just leave that negative outside. So we had 5 times 5 times 2, which is equal to what?
5 is 25 times 2 is 50.
Good. Okay, why didn't we do this?
You can't
Can't.
do with a negative.
Square root of negative.
Okay, you're right. But what if we did,
times a positive would equal.
or a negative times a negative would be a positive, right? So if we did that, so we'd have positive 25 times 2, which this would give us
Positive 50.
positive 50, right? Which is not right. Okay, so just leave that negative outside, please. Okay, so negative 2 cube root of 5.
Okay, so we would have had
1 5.
2
So we would have
2 2s and 1 5. So it'd be-
Careful, cube root.
no, it'd be 6 2s and 1 5. Oh wait, no, what was that? No.
It'd be 3 2s.
There
3
we go.
2s, yeah.
And what are we going to do with the negative?
Leave it outside.
Leave it outside, good. So indicate that it's the cube root there. And then we get 2 times 2 times 2 times 5, right? If it's a cube root, you're going to have 3 of them, right? Just like if it's a square root, you only have 2 of them, right? So 2 times 2 is 4, times 2 is 8, times 5 is 40. So negative 2 cube root of 5 is equal to the negative cube root of 40. Okay, I have a good challenge for you guys here.
This one?
Arrange from least to greatest without using a calculator. If you guys get this right, I will give you candy. Alright, so it's kind of hard to tell in this form here which number is the greatest, right? So when you have a mixed radical and you're asked to rank them, okay, just put it back into a, what do we call it? If it's an entire radical, okay? If you have a mixed number and you're trying to rank them, just put it into an entire radical, okay? So 6 root 5 goes to 6.6.5, which is 180, right? 12 root 2 goes to 12 times 12 times 2, which is, so 144 times 2 is 288. 5 root 5 becomes 5.5.5, which is root 125. And then lastly, 3 root 31 becomes 31 times 3 times 3, which we get root 279. Okay, so what would give us the largest number?
12 and 2.
12 and 2, right? We're ranking it from least to greatest. Which one will give us the smallest number? This one, and then this one,
And then the far right one.
this one, and then this one. So if you want it to be really, really proper, you would go 5 root 5 is less than 6 root 5, which is less than 3 root 31, which is less than 12 root 2. I am okay if you leave it in like your circles. Okay, if you leave it like that.
Quiz?
What?
Is this gonna be a
Honestly,
question?
I'd be fine with doing it.
I actually haven't looked at
Easy.
the quiz yet.
Oh.
Well, that's a lie. I looked at the 4.2 quiz is what I looked at. But yeah, you might see this question like on a unit test or something. Okay, so without your calculator, is 8 root 3 automatically larger than 6 root 5? Just because 8 is bigger than 6?
No, 6
No.
root 5 is bigger.
Is it?
6 times 6 times 5.
6 times
It's
6 is
180.
36. Oh no, 8 times 3 is bigger.
How can we
8
tell
times, 8
for
times
sure?
8 is 64. 64 times 3 is 120, 180.
Yeah.
And 6 times 6 is 36 times 5 is 30, 60, 90, 120, 150, 150, 156,
So-
170. They're awfully close to making the same number.
So yeah, they are close. But how can we tell for sure? Well, you can just do it exactly what Cody was just doing. You can just put it back into your terms, right? So if it's 8 root 3, it's 3 times 8 times 8, which gives us root 192. And if we go to 6 root 5, it's 6 times 6 times 5, which is root 180. Okay? So, no, it's not automatically bigger.
No.
In this case, it is, right? But if you had if this was a 10, right, then this would be bigger, right? It just depends on the radicand, okay? Remember, the radicand is the number underneath the square root sign, right? Okay, almost there. So, how could you estimate the value of root 58 without using a calculator? Not to worry about that. Let's skip that. Okay, so this is a need to know, and this is where we're going to finish off today, okay? So, a radical is in simplest form when the exponent of the radicand is less than the index of the radical. So example, if we had a 12 square root of 3, okay? When the exponent of the radicand, so here it's 3 to the 1. So this is the exponent of the radicand, is less than the index of the radical. This is the index. Okay, so when the exponent of the radicand is less than the index of the radical, it is in the simplest form. Okay, so this one is good. So when we say that the exponent is less than the index. Okay. Yeah, good. We just had a couple examples here. So like this one, 12 root 4, right? This is the same as 12 root 2 squared, right? Because the exponent is the same as the index of the radical. This is not in fully simplified terms, right? Not in simplest form. That one here. But this would be here, right? Okay. A square has a principal square root, which is positive, and a secondary square root, which is negative. Okay, remember, anytime you take the square root of a number, you get a positive and a negative number, right? So we call the principal square root. So if we were, let's say we're doing root 16. So the principal square root is going to be 4. And the secondary square root is equal to negative 4. Okay, lastly, if you express an answer as a radical, then the answer will be exact. If you put the radical in decimal form, the answer will be an approximation, except for when the radicand is a perfect square. Okay, so for example, root 12 is equal to root 2 times root 2 times root 3, which is equal to 2 root 3. So this would give us an exact value. Okay, and secondly, right, so if you just take the square root of 12, you'll get 3.464 ... right? It's an approximation. Because somewhere along the line, you rounded somewhere, right? So it's not an exact value. Yeah, when you want like really precise measurements, you would use radicals and not an approximation from a decimal. Okay? Alright, so that is mixed and entire radicals.
Oh, so now we have an assignment.
Make sure to like and subscribe.
And make sure to like and subscribe
First link in bio.
and do your homework.